Okay, today we are going to talk about products. Oops. What is going on? Products and quotients of rational expressions. So let's just remind ourselves that when you have two rational numbers, say a over b, and you multiply and c over d, and you multiply them, what you get is the product of the two numerators, so a times c, divided by the product of the denominators, b and d. So it's a times c divided by b times d. Now when you have a rational expression, like x minus 3 over x, and you multiply it by another rational expression, like x plus 5 over x plus 2, let's think about what this is going to mean. Remember, x is a symbol, but it stands for a number. I mean, numbers go into x. So if you imagine replacing x by a number, then x minus 3 is a number. So x minus 3 divided by x is a number, right? If x is a number. And similarly, x plus 5 divided by x plus 2 is also a number. So I also have if x is a number, okay, then I'm going to get a fraction times a fraction. And I can multiply fractions by multiplying the numerators and denominators. So this is going to be equal to what I get when I take the two numerators and multiply them. Divided by what I get when I take the two denominators and multiply them. And let's distribute the top. What do you get? I get x squared plus 2x minus 15 on the top, and on the bottom I get x squared plus 2x. Okay. Of course, this is assuming that the left and right hand sides are defined. So x is not equal to 0, and x is not equal to negative 2. Because if x were 0 or negative 2, then the denominators would be 0. Okay. So in general, let's do some more complicated examples. You would factor the numerator and denominator, each of the numerators and denominators, and then divide them by their common factors. And here's an example. Let's simplify 3xy over 7wy times 14w squared over 18x. Well, what I'm going to do is I'm going to write each of these numerators and denominators as factored as possible. So this is going to be, well, 3xy, I can just write as 3 times x times y. The denominator I can write as 7 times w times y. And then I have times 14w squared. Well, w squared is w times w, and what's 14? How can I factor 14? 2 times 7. So 2 times 7 times w, all over 18x 18 factors as 2 times 3 times 3. And then I have an x. So what I have is I am multiplying everything together. I'm multiplying everything in the numerator and everything in the denominator. Now, hopefully we know that we can cancel. When you have factors on the top and bottom, we can cancel. So what terms can we cancel? Well, this 3 on the top, I can cancel with the 3 here. The x, can I cancel this x with, do I have an x in the denominator? Yes, I have, let's use a different color. I have that cancels with that. Maybe I'll use green. Okay. I also have a y on the top. Is there a y on the bottom? Yeah, there's a y on the top and bottom. I can cancel those. I have a 2 on the top. Do I have a 2 on the bottom? Yes, I can cancel those. A 7 on the top and a 7 on the bottom. I can cancel those. I have a w on the top. Is there a w on the bottom? Yes. And what I have left is a w on the top. Is there a w on the bottom left? No, there's just a 3. So the result I'm going to get is w over 3. Now let's just remind ourselves that canceling only works when you have a factor on the top and bottom. Not when you have a sum or when you have a difference. Only when you have a product. And let's just, okay, I'm just going to do this kind of on the side, but let's just remind ourselves why if you have, say, 3xy over 6y, I can do some cancellation. The reason is because I have 3 times x times y all over 3 times 2 times y. This is the same using the properties of multiplying numbers. This is 3 divided by 3 times x divided by 2 times y divided by y. Now 3 divided by 3 is the same as 1. And when I multiply anything, in this case x over 2 times y over y, if I multiply that by 1, I don't change the value. So this is going to be equal to x over 2 times y over y. Similarly, y over y is equal to 1, and this is assuming that y is not 0. And since y divided by y is equal to 1, x over 2 times y over y is the same as x over 2 times 1, that's x over 2. So that explains the canceling with the 3's and the y's. I get x over 2. Okay. It's very important to understand that. Okay, let's do another example. And from now on, we're not going to keep saying the restriction that, so here maybe I should have said that w is not 0 and x is not 0 and y is not 0, so that the expression is actually defined. Okay, but I won't really keep writing that. So we're just assuming that this is only happening when these expressions actually exist. Because if you look at this, okay, if w is 0, you don't get anything. I mean, this expression is not defined when w is 0. However, this expression, w over 3, is defined when w is 0, right? This is defined when w is 0. I mean, if w is 0, you just get 0 over 3, that's 0. But this expression, this quantity, is not defined. Why is it doing this? Okay. Not defined when w is 0. So You should say that these two expressions are equal when w is not 0, because if w were 0, then w over 3 would be defined, but then the original thing is not defined, so they can't be the same thing, right? So it's technically, we should say that these two are equal when w is not equal to 0. But I'm not going to worry about that. Okay. Let's just focus on simplifying the expressions. So here's another example. Simplify 3x squared plus 3x over 6x squared minus 6x times 7xy minus 7y all over 5xy minus 10y. Well, it looks a lot more complicated, but we do the same thing. And when you have these expressions, we have complicated expressions, it's a good idea to kind of on the side factor each of the terms and then put them together later. So 3x squared plus 3x, what can I factor out? Well, I look at the coefficients, 3 and 3, I can factor out a 3. And when I look at x squared and x, what can I factor out? I can factor out an x. So I can factor out a 3 times x, and when I factor out a 3 times x, I'm going to get what? X plus 1. Okay? Let's look at the other numerator. So 7xy minus 7y. I look at the constants, 7 and, well, 7 or negative 7. What can I factor out? I can factor out a 7. And then I have a 7xy and a 7y. So when I look at the variables, what can I factor out? I can factor out a y. So I can factor out the 7y, and what am I going to get? I'm going to get x minus 1. Now let's look at the denominators. 6x squared minus 6x. Well, when I factor out, I can factor out a 6x. So I'm going to get 6x times x minus 1. Now the 6 I can factor as 2 times 3. That's going to be useful, remember, when we are simplifying. So I have 2 times 3 times x minus 1. Finally, 5xy minus 10y, I can factor out a 5y. And what do I get left over? X minus 2. So now let's put all that together and rewrite the original expression using the factored forms. I'm going to get 3x times x plus 1 all over 2 times 3 times x minus 1, and then times 7y times x minus 1, and then all over 5y times x minus 2. Now again, here all I did was I just replaced those 4 expressions here by what I got when I factored. And when I do that, I get this. So now I'm trying to simplify this. And again, we just have multiplication, right? All I'm doing on the top and bottom is I have a product. I have 3 times x plus 1 times 7 times y times x minus 1. On the bottom, I have 2 times 3 times x minus 1 times 5 times y times x minus 2. So now I can cancel the factors on the top and bottom. So let's start from the top and go to the right. So I have this 3 on the top left. Do I have a 3 on the bottom? Yes. Right, this 3 and this 3. I have an x. Do I have an x on the bottom? Yes. I have a x plus 1 on the top. Can I factor anything on the bottom? No. Can I multiply that or cancel that with anything on the bottom? No, right? I have a 7 on the top. Is there a 7 on the bottom? No. I have a y on the top, and there is a y on the bottom. I have an x minus 1 on the top, and I also have an x minus 1 on the bottom. So what I'm left over with is equal to x plus 1 on the top times 7 in the numerator. And the denominator, I have a 2, and then I have a 5, and then I have a times x minus 2. And I'm going to, well, you should multiply the numbers out, and normally we have the numbers out in front, right? So this is 7 times parentheses x plus 1 all over 2 times 5 is 10 times parentheses x minus 2. So that's what I get when I simplify. Okay, let's do one more of multiplying, and then we'll do dividing. So simplify 2n minus m over 2m squared plus 7mn plus 3n squared times 2m cubed plus m squared n over m cubed minus 2m squared n. Okay. Well, again, I'm going to see if I can factor anything. This 2n minus m on the top left, I can't factor that, so that's just 2n minus m. For 2m cubed plus m squared n, what can I factor out? I can factor out an m squared. And then I'm going to get what? 2m plus n. Then for the bottom, 2m squared plus 7mn plus 3n squared. This looks like something I can factor because I have quadratic expressions. So let's see. Since I want a 2m squared, so I'm going to get something m plus something n times something m plus something n. And I want these numbers, when I distribute, I'm supposed to get 2m squared. So I want those two numbers to multiply to 2, so let's try 2 and 1. Now if you think about it, that's really the only option, because you have 2 and 1 and 1 and 2. Well, that's just going to switch the order, okay, but that's fine. And then negative 2 times negative 1. But if I have a negative 2 times negative 1, I can factor out a negative 1 from each of the terms, and then I'm going to get a plus 1 when I multiply. So I can just make them 2 and 1. And this 3n squared. So I want these two numbers to multiply to 3 so that I get a 3n squared. So there's really only a few possibilities to check. You want to make it so when you distribute, you get a 7mn. And if you do 3 and 1, that's going to work. Like this. Because then I'm going to get, when I distribute, I get 2m squared plus 6mn plus mn plus 3n squared. So this factors as 2m plus n times m plus 3n. Okay, now I have m cubed minus 2m squared n. I can factor out an m squared. And then that'll leave me with m minus 2n. So let's write this all out. The original thing is equal to 2n minus m times m squared times 2m plus n all over 2m plus n times m plus 3n. Did I get that right? Oh, and I still have an m squared times m minus 2n. Okay. So again, we're going to see if we can cancel. Again, we've written something where it's all just multiplying, right? I have a 2n minus m times m squared times 2m plus n. And on the bottom, I just have a product of terms. So we can try to cancel. Now this 2n minus m, this one's a bit tricky because I don't see a 2n minus m on the bottom. We'll come back to that. Let's look at the m squared. Do I have an m squared on the bottom? Yes, so those are going to cancel. This 2m plus n, do I have a 2m plus n on the bottom? Yes, right? Now, going back to the 2n minus m, notice there's an m minus 2n there. Now those are almost the same. Actually, if I multiply, notice that if I take 2n minus m and multiply it by negative 1, I get negative 2n minus negative m, that's plus m, and that's the same as m minus 2n. Right? So this is negative 1 times 2n minus m is m minus 2n. So actually, if I take 2n minus m, that's the same as negative 1 times m minus 2n. So if I divide both sides by m minus 2n, I get 2n minus m over m minus 2n is equal to negative 1. So actually these do cancel, but I have negative 1. So I can replace, if you want, I can just do this extra step where I replace the 2n minus m because that's the same as negative 1 times m minus 2n. And then I can cancel out the m minus 2n's and I'm left with negative 1. So altogether, I have negative 1 over m plus 3n. Okay. We also have the quotient. When you have two rational numbers, a over b and c over d, but instead of multiplying, you divide, it's defined to be a over b times d over c. So you multiply by the reciprocal, and of course when you multiply fractions like this, you multiply the top over the bottom. And again, since our variables are standing for numbers, the same works when you have expressions. Let's do a few examples of this. 2x squared plus xy over x cubed plus x squared y divided by xy minus y squared over x squared minus y squared. Well, first thing I'm going to do is I'm going to change this to a multiplication. So right now I'm dividing, right? Let's change this to a multiplication. So I'm going to be multiplying by the reciprocal. So I keep the first expression the same, but now I'm multiplying by the reciprocal, x squared minus y squared over xy minus y squared. And now I just do the same thing as before. I can factor. I'm just going to factor the, just to save time, I'm just going to factor directly instead of writing it out separately and then putting it back together. So on the top, 2x squared plus xy, I can factor out an x, and then I'm going to get what? 2x plus y. And then on the bottom, I'm going to factor out x squared, and then I get x plus y. This x squared minus y squared, how do I factor that? That's x plus y times x minus y. The difference of squares. On the bottom, can I factor that? What can I factor out? I can factor out the y, and I'm going to get x minus y. And now, again, I have a product, and I'm trying to cancel things out. So remember, I don't necessarily want to write out this whole thing all over again, but just to emphasize what's going on, I have this product of 4 terms on the top. On the bottom, I also have this product of 4 terms. And I'm trying to simplify. So this x on the top, can I cancel with anything on the bottom? Well, I have an x squared. Remember, x squared is x times x. Let's just change the x squared to x times x. Now I have an x on the bottom. Okay? I can cancel these out. Is 2x plus y on the top? Do I have anything on the bottom? No. What about the x plus y? Yep, there's an x plus y on the bottom. X minus y, yep, I have an x minus y on the bottom. So I am going to be left with 2x plus y on the top over x times y on the bottom. And that's as simplified as I can make it. Let's do one more where we're putting kind of everything together. So simplify 10xy over 2x minus 4y times x plus y over x squared minus xy divided by xy plus y squared over y minus x. Well, okay, this is more complicated, but not really. I mean, in terms of what you do, first we're going to change the division into multiplication. So I'm going to keep everything the same. Except when I am doing division, I'm doing times the reciprocal. That's y minus x over xy plus y squared. Now I'm going to get a lot of cancellation. So, well, on the top, I actually can't factor out anything. I guess the 10 I can factor out as 2 times 5. So 2 times 5 times x times y times parentheses x plus y times parentheses y minus x on the top. On the bottom, 2x minus 4y, what can I factor out? 2, right? 2 times parentheses x minus y, and then times this x squared minus xy, I can factor out an x, and then I'm left with x minus y. And then xy plus y squared, I can factor out the y, and then I have left over x plus y. And now I can try to cancel things out. So I can cancel out, well, this 2 I can cancel out with the 2 on the bottom. The 5 on the top I can't cancel out. What about the x? Yes, I can cancel out with the x there. The y, I can cancel out with this y here. The x plus y, I can cancel out with x plus y there. Y minus x over, on the bottom I have x minus y. But remember, I have this thing where I swapped the signs. So y minus x is equal to negative 1 times x minus y. Do you see why? Because when I distribute the negative 1, I'm going to get negative x and then plus negative 1 times negative y. That's going to be plus y. So I get y minus x. Okay. Should I just distribute that? Negative 1 times x minus y equals negative x plus negative 1 times negative y. This is equal to negative x plus y. And then that's equal to y minus x. So I'm going to replace the y minus x by negative 1 times x minus y. And now I have an x minus y on the top and bottom. I have factors of x minus y on the top and bottom. So I'm going to be left with, this is equal to -1 at the top. On the bottom, I have an x minus y here, right? This, that. By the way, I can rewrite this as, so this is perfect, -1 over x minus y. If I don't want the, oh, hold on. Oh, I made a little mistake. This should be x minus 2y. Okay, and I also didn't see the 5 here. So actually I should have -5 on the top, and then okay, let's try this one more time. So I should have -5 on the top, and on the bottom I have an x minus 2y. There we go. This is perfect. Now, when I have -a over b, it's a good idea to recognize that this is the same as a divided by -b. So if I wanted to, I could write this -5 over x minus 2y as 5 over 2y minus x. Okay. So I could have written it as 5 over negative, so I shouldn't have skipped that step. I could write it as 5 over negative parentheses x minus 2y. That's the same as 5 over negative x plus 2y. So 5 over parentheses negative x plus 2y. I could have written it like this also. Oh, but either one is not more simplified than the other. Okay, so that is products and quotients of rational expressions.